is perpendicular on AD, it is perpendicular on BC as well. Okay. Therefore, BP is equals to PC, perpendicular.
Ma'am, the another class will be same chapter only.
I think so. I'll be taking the same concept. I'll ask the students over there if they will say that no, they are confident with the questions from circles. Okay, they don't want me to take this one. Then I'll see which chapter I'll start over there. I need to ask from them. But I really want to start take these questions only over there as well because this chapter is really important. If today I'll leave it, then tomorrow or maybe after a few days, the same student will say that can I take the questions again because this is confusing. So I think I'll be taking same. Similarly, again and again, I don't need to write the same theorem. Okay. Similarly, AP is equals to PD. That is equation number one, and this is equation number two. I just need to do the subtraction. That means I'll be subtracting equation two. 2 minus 1 I'll be doing. As I said, subtracting means left hand side minus left hand side and right hand side minus right hand side. So AP minus BP is equals to PD minus PC. And we are done with the proof. After just this step, we can write AB is equals to CD, proved. Is it clear?
Yes, ma'am.
Okay, so yeah, we are done. I think in next class, I'll be able to complete this one and then I can take surface area and volume. If you are done, please let me know. And yeah, anyone having any confusion so far?
Hmm. Ma'am, if I want to stay, can I stay? Or
Yeah,
I,
sure. You
can
can
I
stay in the other class as well.
for a few minutes? I will leave the class.
Yeah, sure. Take your time. Yes, Lokya, Tanisha, Anand, are you done?
Yes, ma'am.
Yes,
Okay,
ma'am.
then yeah, we are done. And yes, I'm keeping this much over here. Thank you. Take care. Bye. I hope this much is clear to you.
Yes, ma'am.
Okay, so yeah, keeping it this much. Thank you. Take care. Bye.
Bye,
Thank you,
ma'am.
ma'am.
Thank you.
Yeah, bye. Thank you.
Thank you, ma'am.
Thank you, Anand. Yes, Gauri, you joined us now.
Yes.
Okay, in the previous batch, circle already has been completed, but still I have taken because few theorems are there. Like it can be confusing. This chapter and quadrilateral chapter can be confusing for students. So they asked me to take questions, and hence I have taken. Over here also, shall I take circles till where I have left and finish it within one or two class, or I can
Yes,
proceed?
ma'am.
Yes.
You can start from where we left.
Okay, so yeah, I'll be taking circles only. Just give me few minutes. I'm starting.
Good evening, ma'am.
Hello everyone, how are you all? Hi Nikhil. Hello Afia. Hi
Good
Chakra.
evening.
Hi Gauri.
Hello, ma'am.
Yes, hello everyone. So yeah, the circle already has been completed. And what is the next chapter which was going on over here? Heron's formula, that is also done.
Yeah.
Okay, so
Yeah.
Heron's formula done. I think that is clear to all of you, right? That chapter is really easy chapter, right?
Yeah, ma'am.
Okay. So circles I'll be taking again quickly. I'll be covering it till where I have left. Okay, I'll be taking few questions because this chapter, even if you are sure that you understood it really well, I want to take it. I want to take it. Okay, because this chapter I want again few questions are there which I really want to explain, and then quickly I'll cover it in. I think in the next class I'll be able to cover this chapter, and then I'll be taking the next chapter over here. Okay. Okay.
Okay.
Okay, so yeah, let's see the questions. Till where I have left, I'm just proceeding from there. First question only I have explained to you. So yeah, let me show you the next second question, third question, fourth question. Okay, just a moment. Let me read the question. So two equal chord of a circle intersect within the circle. Prove that the line segment of one chord are equal to corresponding segment of the another chord. I have read this complete question, but I am not getting anything at all. Okay, I'm not understanding what the statement says. So I need to read it carefully. I need to read it word by word. Let's read it. Two equal chord. Okay, this much is making sense to me that two chords are there which are equal. Equal means equal in length. Two chords equal in length. This much I am understanding. Okay, of a circle is written over here. See, I was not understanding what the statement said. Then I started reading it word by word, and till here it is clear that two equal chord of a single circle we are having over here, and in that single circle two equal chords are there. Intersect. Okay, these two chords are intersecting each other as well. Two equal chord of a circle intersect. That means these two chords which are equal in length, are intersecting each other. That's what is written in the question. I'm not saying, okay, till here it is clear to me. Is it clear to you as well? Just a second, no? Just a moment. Yeah. So we were trying to decode the language first. Here it says that two equal chord of a circle intersect within the circle. Intersect within the circle. We have drawn in that manner only. Two equal chords are there. It is given over here that these two chords are not just random chord. These two are equal chord. okay, intersect within the circle. This much is clear to all of you. Are you able to decode the language?
Yes.
Okay, only this much is clear to me. Then I'll read the next part carefully. Proof that. Okay, I need to show something over here. Next statement is talking about the showing part. Proof that the segment of one chord are equal to corresponding segment of the other chord. Segment means portion. Portion. Okay, segment means portion. If you are suppose you are cutting pizza and I will say I need the bigger segment, that means I need the bigger portion. Okay, so here it says that the segment of one chord are equal to corresponding segment of the other chord. That means the bigger portion, okay, the bigger portion over here, this bigger portion of one chord is equal to bigger portion of another chord, and the smaller teeny tiny portion of this chord is equal to teeny tiny portion of another chord. Are you understanding what does it says? You have to show, suppose this point of intersection is M, then you have to show the bigger portion AM is equals to the bigger portion QM over there, and hence the smaller portion will also be equal. Automatically the smaller will be equal. You need to understand that. If AB completely AB is 5 centimeter, completely PQ is 5 centimeter, and you are saying this black colored part is 3, this is 3, this is 3, then automatically the remaining will be same. Yes or no?
Yes.
Okay, so main here it is given that these two chords are equal in length. AB, the chord AB and the chord PQ are equal in length, okay, and are intersecting each other. These two are intersecting each other inside the circle like this. Then prove that segment, corresponding segment are equal. Corresponding segment are equal. That means bigger portion here and bigger portion there, equal in length. Hence, smaller will also be in equal in length. So here, if we will target to prove this one, if we will target that, let's prove this one. Okay, automatically BMPM will be same. We don't have to worry about that. Is it making sense? Is it making sense?
Yeah. Yes.
Okay, so yeah, let's see how we will prove that AM and QM are equal. Here we have to take the help of few theorems. The theorem which you have already learned. First of all, you tell me whether this question is clear to you or not. Is it clear?
Yes.
Okay, the question is clear, then let's see the approach. As I say, don't copy anything. Maybe you are already having the solution. So let's try understanding what concept will help us. First of all, I this is a circle and there is a chord AB. AB chord we are having. From the center, we will be dropping a perpendicular on this chord. From the center, we will be dropping a perpendicular on this chord. Okay, let's say OS. It's the perpendicular. Perpendicular from the center, bisect the chord. Yes or no? Right? Right?
Yeah.
Okay. So we understand that AS, BS will be equal. Nothing but half of AB. Right?
Yes.
Right? Because perpendicular from the center on any chord. On any chord. Are you able to recall the theorem that if you are having a circle and if there is any random chord, maybe of 7 centimeter, and if I'll drop a perpendicular from the center, it will bisect my chord. It will divide it into equal part 3.5, 3.5, right?
Yes.
Okay, so
Mm.
perpendicular from the center on the chord, bisect the chord. So our chord is getting bisected. We will do this construction. We will drop perpendicular from the center. Now one more thing I'll show you, just a moment. We are having another like the same circle, another chord PQ, and on this chord also I am going to drop a perpendicular from the same center. Okay, from the same center. Oh, in a circle, in one circle, so many centers we will not have. So one center is there, that is O. From the O, we are dropping perpendicular on AB, and from the same O, we are going to drop a perpendicular on this PQ. Okay, and here also we will say now our chord PQ will get divided in two equal parts. That means PT PQ is equals to half of PQ. Making sense? This much is clear to all of you.
Yes.
Okay. Now, after this one, we are going to say, over here that since we know these two chords are equal in length, since we already know these two chords are equal in length, the complete AB and the complete PQ are equal. That means half of AB and half of PQ will also be equal. Okay, that means this black colored part, I mean, no, not this black one, I mean this one, AS. Let me drop the perpendicular. That means this AS over here and this QT over here, okay, it is equal. Yes or no? Yes or no?
Yeah.
Carefully. AS is half of AB, and here PTTQ both are half of PQ. So half of AB, at the place of half of AB, I can write AS. And at the place of half of PQ, I can write TQ. Okay, or QT. This green, that green is same due to half. The complete AB, the complete PQ same. Okay, that means half of AB and half of PQ will be same. Okay, that green, this green will be same. Making sense? So far it is making sense to all of you.
Yes.
Okay, you are just having a circle. I am wiping everything. Don't copy anything. Just try understanding the concept. You are having the center. You are having the circle. You are having a circle. There are two chord AB. You are dropping the perpendicular from the center like this and calling it S. So of course this AS, BS are equal. Okay, you understand that. There is another chord as well, PQ. You are dropping a perpendicular on this chord, OT. So of course this PT and TQ are same. Okay, if complete AB and complete PQ are equal, then half of, if complete AB and complete PQ are equal, already given in the question. Okay, then half of AB, half of PQ will be same. That means AS and PQ will be same. Is it clear so far? Is it clear
Yes.
so far? Okay, and after that we are going to just join it with the point of intersection M. O, center and point of intersection we are joining, and very easily you will be able to prove this two are congruent triangle. These two are nothing but just congruent triangle. Very easily you will be able to prove. I don't even have to help you for that. These two are congruent. I'll show you how. These two are congruent. Okay, 90-degree you have dropped here, 90-degree you have dropped here. Common side you can clearly see. Okay, and equal chord are equidistant from the center. If you are having a circle, if you are having a circle, in that circle, if you are having two chord, random, just random two chord, this is 5 centimeter and this is also, let's say, 5 centimeter, then you will find the distance from the center, okay, of the first chord and of the second chord. These two distances will be same. Automatically you will find that this distance is 3 and this is also 3. This will only happen if your chords are same length chord are at same distance from the center. Do you know that equal chord are equidistant from the center? Yes or no?
Yes.
Okay, so this distance OS and this distance OT, perpendicular distance, Okay, in first class I was talking about distance means perpendicular distance. In coordinate geometry chapter also you have learned, if a point is there, you have to draw perpendicular on x-axis and perpendicular on y-axis. So distance means perpendicular distance. Equal chord are at equidistant from the center. So if AB chord and PQ chord are equal, then their distances from the center will be same. The distance of AB from the center and the distance of PQ from the center will be same. Distance means what? Distance means from the center you have to drop a perpendicular. From the center you have to perpendicular on both the chord. Those distances will be same. Not random distance. Making sense? Okay, so this OS OT will be same, and easily, very easily you will be able to prove this purple color triangle and this blue color triangle are congruent. It is congruent, you will be able to prove it. Okay, and the moment you will prove this two are congruent, then you will be able to say this orange color part and this orange color part are same by CPCP. And we are done with the proof. Now we will say green plus orange over here and green plus orange over there are completely okay. This green one plus orange one, and there also green one plus orange one. Can you see the proof? AMQM. Can you see? Can you see the proof?
Yeah.
AMQM. We are done with the proof, right? We are done with the proof,
Yeah.
right? We are done with the proof. Okay. So again, I will summarize till the time it will be in your mind and you will understand, okay, this is how you have to approach it. So you are having a circle. You are having a circle. There is a chord. There is a chord. These two are not random chord. These two are equal chord which are intersecting each other. Okay, intersecting, just intersecting each other. Then we have to prove the segment, corresponding segment are equal. That means the bigger portion and the bigger portion are equal with each other. The teeny tiny portion and the teeny tiny portion are equal with each other. That's what we have to prove. We realize that if we will prove that bigger portion equal, then automatically the other one will be equal because the chord are equal in length. Okay, now at first we are dropping a perpendicular on this chord AB. We are dropping a perpendicular OS, and we are saying that now our chord is getting divided in two equal part. AS BS same, both are equal to half of AB. So we are dropping a perpendicular and we are saying ASBS same, both are half of AB. ASBS same, both are half of AB. Similarly, same thing we are doing in the other with the other chord as well. We are drawing PQ. Here is the center. Okay, we will drop the perpendicular OT and we will say here also the chord is getting divided in two equal part. PT QT same, which is equals to half of PQ. Okay, PT QT both are same, which is equals to half of PQ. Now here only we need to understand that the complete length AB and the complete length PQ is same. That means half of AB and half of PQ will be same. While taking half of AB, please don't get confused. I don't want you to get into the loop of going here and there and searching that which side you will be taking. Half of AB is strictly you will be taking only this much. Strictly, you need to just keep this figure in your mind. Half of AB means AS. Okay, you can think about maybe AS, maybe BS, but be clear, AS you will be taking. AS. Half of AB means AS. AS. And half of PQ means this QT you will be taking. Otherwise, you will keep on getting here and there and you won't be able to prove. So half of AB means AS and half of PQ means this TQ. Making sense? Making sense?
Yes.
Okay, these two are equal. These two are equal. Now, due to congruency, you will join this one. Due to congruency of this triangle and this triangle, which is really simple to prove. Due to congruency of this triangle and that triangle, This much length and this much length is same. Hence, we are done with the proof. Is it clear? Is it clear?
Yeah.
Is it clear to all of you?
Yes, ma'am.
Okay,
Yes.
now I'll write the steps properly. So anytime when you are practicing this particular question at your home, first of all, you need to understand what the question says. If you will read the question in one go, you won't be able to understand. You have to read it carefully, step by step. Once you understand what the question says, you need to recall how we were solving this question. I would not say this is a question where you can think maybe this way, maybe that way you can do. No, please follow this way, otherwise you will end up getting confused. Okay, so you are having a circle. There is a chord AB, there is a chord PQ. Both are intersecting each other. Maybe the point of intersection is M. There must be a center. We are dropping the perpendicular from the center. We are dropping the perpendicular from the center. So construction I am writing that OS is perpendicular on AB and this OT is perpendicular on PQ. And due to this perpendicular, our chord is getting bisected. Okay. So we will see, which implies that this AS, and here so many things you can see, so the chances are you will end up getting confused, and please don't get confused. AS and BS are equal. Perpendicular is dividing the chord, okay, in two equal parts. So AS BS are same. Don't get confused with this MP BM. Okay, so many points. Your AS BS is same. If you are getting confused, draw the circle separately. Draw just chord AB, you will understand. Is it making sense?
Yes.
Okay, this is the perpendicular which is dividing the chord. That's it. Okay. So we will say that AS is equals to BS. That is equals to half of AB. Here also we will say that the other chord is also getting divided. The moment we are dropping a perpendicular OT, our chord is getting divided. This QT and PT, even though it doesn't look same, it is same. It is same. Okay, figure, maybe the figure is not justifying, but it is same. Perpendicular from the center bisect the chord. Okay, it's, I have not drawn the figure properly. And if you will draw the figure like that, it is completely fine. Nobody will ask you why you are saying like that, even though the figure is not showing. It is. Okay. PT and QT are equal. Clear so far?
Yes.
Now we'll be taking this two triangle OSM and triangle OTM. I'm not going to prove it congruent because you will be doing it. You will be proving it congruent. Okay. I will not do. You will say that 90° here, 90° there. OM is the common side, and the extra information which you need to be careful with is OS is equals to OT. Equal chord are at equidistant from the center. Okay, you just need to write all the information properly. Okay, congruency I'm not going to show. You will write the information, you will write the information, and then you will say triangle OSM, it's congruent with the other triangle OTM. By RHS, it will be congruent, that I can tell you. Okay. Why we have proved this two congruent? So that the orange color portion over here and the orange color portion over here will be same. I mean SM over here and TM over here will be same. Making sense?
Yes.
Yes.
Equation number, let's say 2. This was 1. Okay, this relation which we have obtained after construction, that was 1. Okay, now we will say that we already know. We already know AS and PQ are same. Okay, but we need to write it properly. So let's write it. We know AB and PQ are same. That means half of AB and half of PQ are same. Now, after writing this one, I want you to be really, really, really careful. Otherwise, here only you will end up getting stuck. Okay, half of AB, half of PQ, that much is clear to you. But if you will not write it properly, that the black color portion over here and the black color portion over there, then you will end up getting into the loop of going here and there and not be able to doing the proof. Making sense? Okay, so carefully you have to take half of AB I am taking as AS and half of PQ I am taking as a, carefully we are taking as a QT. Okay, not randomly you will take anything and you will end up doing the proof. AS and QT. Now we will say this is equation number 3. Now adding equation 2 and 3 will give you the proof. Clear? We will just add equation number 2 and 3. Is it allowed in mathematics adding any two equation? It is completely allowed in mathematics. You can take any two equation and you can add the left hand side with the left hand side and the right hand side with the right hand side. Making sense? So the
Yes.
moment you will add equation number 2 and 3, you can say we are done with the proof. The green color highlighted part which I have written on to show, I mean the showing part, AM is equals to QM, that will be able to say directly, just adding 2 and 3. Is it making sense to all of you? The proof, the figure and the explanation?
Yes.
Okay. After this class today, you will be drawing a circle. You will say in your mind that I know AB and PQ are equal and I have to prove that the bigger portion over here and the bigger portion over here are equal. Okay, just try doing it in the rough portion and check it. Are you able to do it or not? Please do copy if you want to copy. If you already have the solution, then please let me know. Yes, Afia, Chakrika, Gauri, Nikhil, are you copying?
Yes, ma'am.
Yes, ma'am.
Please do it. Let me know once you are done. Are you done, Gauri?
Ma'am, 1 minute. I'm in the last step, ma'am. 1 minute, ma'am.
Yeah. Take your time. Yes, Chakrika, Afia, Nikhil, if you are done, please let me know.
Yeah, ma'am, that's
Yes,
it.
sir.
I'm going to.
Okay.
Yeah, I'm finished.
Okay. Let's move. Let's see the next question. See the next one. First of all, if you are struggling with anything, the circle or the quadrilateral based question, that means you need to understand the question really well. If we will not understand the question, if I will not understand the statement, I won't be able to solve it. Okay, it's simple. So if I'll read it, if two equal chord of a circle intersect within the circle, prove that the line joining the point of intersection to the center make equal angle with the chord. I'm not getting anything. I'm not getting anything. Whenever I read question like this, I don't get anything. If even if the student, sometimes student come with extra questions, and if I read like this, I don't get anything. So what I do and what you have to do, if two equal chord of a circle, a circle is there and two chords are there which are equal. That much data we are having in our mind, and that is clear. Okay, it's clear that a circle is there and two equal chord is there. Intersect, just like the previous one, maybe. Okay, within the circle. Intersect within the circle. Two equal chord of a circle intersect within the circle. Two equal chord intersect within the circle. If meanwhile I will feel that my figure is incorrect, quickly I'll rub it. Okay, I'll rub it and will start properly. But for now, whatever I am getting, I have drawn it. So two equal chord of a circle intersect within the circle. Given that two equal chord are there, before I will, okay, if I'll read the next part, the chances are I will end up forgetting that these two chords are equal. So quickly I'll write that these two chords are equal. Quickly I'll write that these two chords are equal. Is it making sense to all of you? Now prove that the line joining, okay, I have to be careful. Prove that the line joining the point of intersection is this one. Okay, M. The line joining the point of intersection to the center. The line joining the point of intersection to the center. It says, I'm not saying, see here it is written, the line joining the point of intersection to the center. Okay, line joining point of intersection to the center makes equal angle with the chords. This line OM is making same angle with the chords. This line is making same angle, equal angle with the chord. That means angle M over here is equals to angle M over there we have to show. Making sense? Making sense? Okay, it's great. This is really simple. Okay, this is really simple. We understood that we have to show over here that the line joining the point of intersection to the center make equal angle. This line is making equal angle with the chord. Okay, the chord over there, the chord, it is making same angle with the chord. That means basically we have to prove that angle OMP, wait, OMA is equals to angle OMQ. That's what we have to show. Just now we realize that the moment we will drop a perpendicular over here and a perpendicular over here, it's really simple to prove these two triangles are congruent with each other. Yes or no?
Yes.
Okay, and if these two triangles are congruent with each other, then this two angle will be same by CPCT. Proving congruency is really easy. Okay, 90° here, 90° there. OM is the common side, and equal chord are at equidistant from the center. Yes or no?
Yes.
Okay, so this one is easier than the previous one. Here, what we will do? Here we will just do the construction, and it is easier only because we have understood the previous one really well, and we have understood the statement over here really well. That's why it is easier. We will just write the construction we are doing, that OS is perpendicular on the chord AB and OT is perpendicular on the chord PQ. This perpendicular will help. Our chord is getting bisected. Okay, so many information we don't need, because we will just say that in this two triangle, the green one and the blue one, 90° here, 90° there, and OM is the common side and equal chord equidistant from the center. Just that we will say. Okay, chord is getting bisected and all, we don't even have to write it over here. Is it making sense?
Yes.
Okay, these two are congruent, hence angle M over here, angle M over there are same, and hence we are done with the proof. Please finish it quickly. Is it making sense to all of you? Then only finish it. Otherwise, you will say that you are not even understanding. Is it clear to all of you? Nikhil, is
Yeah.
it clear?
Yes, ma'am.
Chakrika, Afia,
Yes.
continue. Let me know once you are done. Are you done?
Yeah, I'm done.
Yes, everyone. Chakrika, Afia. Is it done? Yes, Chakrika. Afia, are you done?
Yes.
Okay, let's move. Now the next question. See what the question says over here. If a line intersect two concentric circle, okay, the figure was already given. Let me draw the figure. Here we don't have to think about the figure and all. Okay, already the figure is drawn. So if a line intersect two concentric circle with a center O at ABCD, prove that AB is equals to CD. Okay. In another batch also, I was telling just one incident, and here also I am okay. I definitely want you to know that just yesterday only one of my neighbor kid just came to me. Since I'm maths teacher, sometime here and there a student do come to me for help. So from the neighbor, one of the kid came to me for help, that construction is there now in class 7, and I'm not able to do the construction of triangles with the help of circles and all. Okay, I'm not even able to he is not even able to draw the circle properly. Compass he is using for the first time and is not able to draw circle properly. Then I said, why are you trying to do the construction? First get familiar with the compass and make random flowers, shapes, or anything. So he has taken A4 sheet paper and started drawing circle like this. A circle, a circle, a circle, a circle, a circle. And he said that, see what I have drawn. Now I am comfortable. Okay, because I was just playing with the circles and all, and this is something I have drawn. I am comfortable now. I can draw circles and I will be able to do the construction, I think, in a better way. Then okay, I said, okay, just take a pause and see what you have drawn. This is concentric circle. This is concentric circle. That means you have pressed the needle of the circle at a point O and you made one circle. Then without lifting the needle from O, you just stretch the arc and made another circle. Without lifting the needle of the compass from O, you just stretch the arc. That means you change the radius and you made one more circle. And just like that, you have drawn so many circles where the radiuses are different, but the center is same. And that's called concentric circle. That means all the circles are having the same center. Making sense?
Yeah.
Okay, that's called concentric circles. So why I'm telling you this story? Because I found in your question concentric word is mentioned. If today I will tell you that you can see the figure, let's continue. Okay, then you will not be getting what is the meaning of this. And in class 10 again and again you will encounter concentric circle will be there. Concentric circle means 2, 3, 4, 5, 10, 20 circles are there where the center is same. Is it clear? Is it clear? So here we are having concentric circle with center O at, and if a line intersect two concentric circle at with a center O at ABCD. So line is intersecting the concentric circle, okay, at A, at B, at C, at D. Then we have to prove that AB is equals to CD. Now I will just take a smaller circle from here and see carefully. O is the center and BC. Does it looks like a chord?
Yeah.
Does it looks like a chord? Okay, if I'll tell you, let's drop a perpendicular on this chord OP. That means your chord is going to get bisected. BP is equals to CP. That means perpendicular from the center bisect the chord. Yes or no? no matter it is concentric or what. We have just seen there is a circle, there is a center, okay, and BC look like a chord. So we have dropped a perpendicular on the chord from the center. Making sense?
Yeah,
Yes,
ma'am.
ma'am.
Okay. Perpendicular from the center bisect the chord. Next, this was step 1. Next, I have focused that the bigger one also looks like, okay, separately I can think of it. I don't have to draw it separately, but I'm just trying to show you. The bigger one, it's a circle, and this AD, does it looks like a chord? Oh yeah, it looks like a chord. And center still is O. The previous OP still it's perpendicular, because Euclid said that if you are having a line, it is nothing but just the points attached together. Point. So many point collaborated together is giving you a line. So if there was a perpendicular OP, doesn't matter. Okay, doesn't matter at all. The point, okay, here the point B and C are there or not there, doesn't matter at all. Are you understanding? OP was perpendicular for a smaller one, and OP is perpendicular for the bigger one as well. Yes or no?
Yes, ma'am.
Okay, if a point is sitting beside this P, B, C, or maybe so many other point, it is not going to affect our perpendicular line. Yes or no?
Yes, ma'am.
Okay, it is perpendicular. So perpendicular we have dropped OP. Okay, in both the cases, this same perpendicular we will be taking. That OP is perpendicular to BC, hence chord is getting bisected. We will say OP is perpendicular to AD. We will say this OP is perpendicular to AD. That means chord is going to get bisected. AP is equals to PD. Making sense?
Yeah, ma'am.
And we are done. If you are thinking how, so I am going to say this AP and PD are equal, and this BP and this PC are equal from equation number 1. Okay, BP CP same. From this orange color length, if you will delete this BP, let's rub it, forget about it. Can you see we are getting AB, just AB?
Yeah, ma'am.
And from there, if I will delete that purple one, delete it, cut it, remove it. Can you see you are getting CD? This is what you were supposed to prove.
Yes, ma'am.
Making sense? Is
Yeah,
it
ma'am.
making sense to all of you?
Yeah, ma'am.
Please do it. Write step 1. First of all, you write the construction. Okay, that you are dropping OP is perpendicular on AD. First of all, you are writing the construction that OP is perpendicular on AD. Okay, then you can say the step 1 that OP, wait, let me open it. Yeah. Yeah, please do it. First of all, write construction you are doing where OP is perpendicular on AD. OP is perpendicular on AD. Then you will write the,
Ma'am,
yeah,
I have wrote this already by my own when you were explaining.
yeah, then
So
it
do
is,
I have to write again?
no, no,
I
no.
wrote it in my way.
Yeah, fine. If you have already written, then yeah, we are done. I'll keep this much over here. In next class, I'll cover this chapter completely.
Okay, ma'am.
Okay, so yeah, Nikhil, if you are done, you can leave. Okay, thank you. Take care. I hope this
Okay,
much.
ma'am. Yeah, ma'am, it's clear.
Okay. Yeah. Thank you. Take care. Yes, Gauri.
Thank you, ma'am. Bye, ma'am. Thank you, ma'am.
Yeah. Please do it.
Thank you,
And if
ma'am.
you are also done, please let me know. Okay, done everyone?
Yes, ma'am.
Okay, then yeah, I'm keeping this much over here. Thank you everyone. Take care of yourself. Thank you. Bye.
Thank you, ma'am. Bye, ma'am.
Bye.